Welcome to the very first session of our streaming processing series, brought to you by Butter Idea. This series' learning objectives are simple and beginner-friendly. In this session, we'll explore the basics of data processing by understanding what streaming is and how it compares to traditional batch processing. Let's get started. Here are the learning objectives for this session. By the end of this video, you will be able to understand the basic difference between batch processing and stream processing, including how batch works with completed sets of data, while stream handles continuous, real-time information. You will also be able to recognize common operations used in both batch and stream processing, and see how these approaches behave differently depending on the task. Next, you'll learn how to relate these concepts to real-world scenarios, so you can better understand where each method is used in everyday systems. And finally, you'll understand when to choose batch versus stream, based on data volume, latency needs, and business requirements. Let's begin by understanding the fundamental difference between batch and stream processing. Batch processing collects data over a period, which could be an hour, a day, or even a week. The data is stored and then processed as a single, large job on the entire block. Stream processing, on the other hand, handles data continuously as soon as events are generated. There is no waiting. Data is processed in motion. Batch data is considered bounded, meaning it has a clear start and end. Typically, batch processing has high latency because the system waits until the entire batch is collected before starting processing. Batch processing is ideal when you need a complete and accurate view of all data for a specific time period. Stream data is unbounded, meaning it flows continuously and often comes from multiple sources. Stream processing operates with very low latency, allowing near-instantaneous analysis and reaction. It is best used when split-second responses matter, and you need to react immediately to live events. Now, let's look at a real-world analogy to make these concepts easier to understand. Imagine you have a warehouse, and stocks with boxes are moving in. In batch processing, all the stock arrives at the warehouse first. You know exactly how many boxes have reached your location, and you move them all at once using a forklift. In stream processing, the stock moves continuously on a conveyor belt. Boxes are processed instantly as they arrive. The warehouse doesn't know when all the stock will finish moving, unless the conveyor or the stream is stopped or interrupted. Often, multiple sources are sending stock to the warehouse at the same time, making it a continuous flow. Let's take a look at some real-world use case scenarios in both batch and stream processing. In the HR and payroll industry, batch processing is commonly used for monthly or bi-weekly payroll runs. All employee hours, benefits, and tax deductions are collected throughout the pay period. Once the period ends, a single large job is executed to calculate salaries and issue payments. This is a massive, scheduled, and repetitive task, a perfect fit for batch processing. In the e-commerce industry, batch processing is used for weekly or monthly inventory reports. Sales data from the past month is aggregated, analyzed, and compiled into reports showing slow-moving versus fast-moving products. This data is then used to update the warehouse or feed into a data warehouse for historical trend analysis. In transportation, stream processing powers ride-sharing GPS tracking. The system continuously processes live GPS data from thousands of drivers and riders. It uses that real-time stream to calculate the most accurate estimated time of arrival, adjust dynamic pricing, and instantly match riders with the closest available driver. In manufacturing, stream processing enables predictive maintenance. Sensors attached to machines stream live data, such as temperature, vibration, and pressure. The system constantly monitors these readings and triggers an immediate alert whenever a value exceeds a safe limit, preventing costly breakdowns before they occur. In summary, batch processing prioritizes high accuracy by waiting for all data to arrive before performing any calculations. Stream processing, on the other hand, prioritizes low latency, reacting to data the moment it appears. Because of that, streaming often requires more complex logic, such as windowing, to eventually ensure accuracy. You can think of it this way. Batch processing is for when you need the full story, a complete picture of what happened. Streaming is for when you need an immediate alert to act the moment something occurs. Batch processing focuses on analyzing static, collected data information that's already at rest. Stream processing acts on real-time, continuous data flow, information that's constantly moving. Or simply put, batch processing reads the book after it's been printed, while streaming reads the words as the author is typing them. That wraps up our discussion on batch and stream processing. We've covered the key differences, explored example operations, and looked at real-world scenarios to understand how each approach works in practice. Thank you for watching. I hope this session has given you a clearer understanding of batch and stream processing and when each method is best used. In the next video, we'll dive into an essential concept for stream processing, state, and we'll explore stateful and stateless operations so you can understand how memory and past information impact real-time data processing. See you in the next session.